Donc, bonjour à tous. Bienvenue à ce séminaire, webinaire, point d'ancrage de 4.0. Donc, welcome to this webinar from the Anchor Point, or Anchor 4.0, as we like to call them. Donc, ce matin, nous avons le privilège d'avoir le professeur Aldo Geuna, qui est un ami de très longue date, qui est professeur à l'Université de Turin au département de sciences sociales. So it's my pleasure to welcome Aldo Geuna, who's a professor at the Department of Social Sciences at the University of Torino in Italy, for those who don't know where it is. Il se spécialise en économie de la science et un projet en ce moment sur les robots et l'intelligence artificielle à l'hôpital. Donc, vous voyez déjà le lien avec la présentation d'aujourd'hui. So today, Aldo Geuna is going to talk to us about the making of a new Technoscience, the impact of CIFAR on
databases.
On databases, but you're going to be talking about deep learning and all that stuff. So his specialty is economics of science, and he's got a project on robots and artificial intelligence in hospitals. So those who are interested in the subject can contact me, and I will put you in contact with Aldo. So without further ado, Aldo, the floor is yours.
Thank you very much. Thank you very much for the invitation. It's a pleasure to be here. So what I'm going to do today in the next, 45 minutes, something like that, is to take you through a project that we have carried out to assess the impact of CIFAR databases. What are CIFAR databases? CIFAR databases are image data sets. I will explain in a bit more detail in a few more seconds, that are at the basis of the development of deep learning. Deep learning is fundamentally being developed in Canada. The first most important paper were published by 3 professors in Canada, Hinton, Lee Kuhn, and Banjo. They won the Nobel Prize for, similar to Nobel Prize for computer science, exactly for that reason. So specifically, we study the impact of these artgraph, of this technological component, so the data sets, and understand if and how had an impact on deep learning. Before the start of the research, actually, I was not even certain on which field exactly they might have had an impact. So the definition itself of the field has been carried out during the process. How did we do that? The methodology we followed, interviews to understand a bit more what was happening. Yes, I've been studying artificial intelligence, but as a lot of people studying artificial intelligence, we actually don't know exactly what it is. Okay, it's the fashionable term, and we all study artificial intelligence. Okay, in the last 1.5 years, I tried to understand a bit more what it was from the technical point of view, and understand a bit more what machine learning is, what deep learning is, and then we did a series of interviews. I will explain you a survey. We were lucky enough to be representative, and I will tell you, and then collected bibliometric data. On the basis of bibliometric data, we run an econometric analysis. So it's a mixed method approach. Again, specifically focus on the impact, whatever scientific impact, so citation to papers, and technological impact, citation in patents. And then we might want to discuss the limitation of these indicators during the discussion. So what did we find? CIFAR was fundamental. CIFAR 10, pay attention, there are 2 databases, CIFAR 10 and CIFAR 100, done in the same year. We are in 2009. Only one had a major impact, the other one not, and I will try to explain you why. It did, particularly in the first period, compared to another extremely important data set, ImageNet, that was published in 2009 in the US, and was attached actually to an extremely important competition. And we compare CIFAR 10 to ImageNet. And then CIFAR 10 still has some importance in science. And surprisingly, still has a lot of importance in technology, and that's a bit the result that we did not expect. Also, we did not expect the role of teaching. Okay? During the interviews and out of the survey, we did identify a major role for teaching using that specific technological tool. For me, an open data set is a technological tool, is this kind of research. Okay, so this is the paper, this is the presentation. Now, if you want to go, you can go, and then if not, we go through all the details. So why to do this? I don't know if you do know him, I hope you do. This is Geoffrey Hinton. He's New York Times, the godfather of artificial intelligence, of deep learning. Okay? Deep learning is one branch of artificial intelligence, but he is the man behind it. He's a British scholar that came to Canada and developed his research. And by the middle 2000s, yes, deep learning was a minority in the department. Okay, they were considered that's not the path to artificial intelligence. He and his colleagues specifically pushed for. Then he moved to Google, and then this article is of 4 weeks ago. He decided to resign from Google to be free to talk about the problems of generative artificial intelligence. So deep learning actually is the base behind ChatGPT. Okay, we talk a lot about ChatGPT, big system. Okay, without deep learning, we wouldn't be here. Good or bad, we don't know. We will know in a few more years, but that's the motivation. And definitely the CIFAR through Hinton had a major impact on what will be the future of human being, I would even say, given the impact of generative artificial intelligence. So specifically, what is the research question? How did CIFAR datasets contribute to the development of deep learning, computer vision? I will explain in a few more seconds. The argument here, as slides before, now deep learning is the dominant paradigm in artificial intelligence. So when you speak of artificial intelligence, yes, you have machine learning, but yes, you have synthetic theoretical approach too, but fundamentally deep learning is dominating. So the paper, available in a week or two, if you're interested. We are doing editing, we are presenting around the world. Daniel, my co-author, now is in Germany to present it in Munich to another conference, and then we get all comments, do a draft, and then put it out in a working paper series, or send me an email to have a copy. So we describe the historical evolution and institutional background of the emergence. We present evidence on the data set, specifically open data set. I will try to convince you that this is a small, simple, not expensive open data set. Very, very different compared to the situation of nowadays, where money matters in this learning fundamentally. And the data set are huge, right? But at the start of the field, it was actually a small, open, easily accessible data set. And then we try to identify some channels of transmission of the impact. Theory, you will read it in the paper, but let me just briefly pinpoint the three components. I'm not interested to discuss it today, but we approach artificial intelligence, deep learning as technosciences, okay? As an hybrid community between practitioner and scientists. Technoscience is another component in which there should be a object that identifies that technology. Okay? In this case, is the data set. The algorithms is what the scientists develop, but without the data sets, they would have not been able to develop that specific algorithm. So the two are together, and then the community, as I will show you, with the analysis of publications and the survey, about 20% of authors are from companies, and they publish, yes, in papers, yes, in Scopus, but a lot of the publications are actually on archives, okay, proceeding of conferences. So that is those are typical characteristics of technoscience associated to the fact that usually technosciences are minorities in department of science because they are something that is not really science, that stuff. And so they're spread around, and then they manage through community formation to build up and become important. Open data, you know all about it, I imagine, in this group. And so fundamentally here I cited as written David. So is the idea of open data set, open science as a fundamental mechanism for contributing to the progress in science and the role of specifically the access to the data. So there is a huge literature there. I don't deal, it's just the reference. Again, I already did in the introduction, but it's artificial intelligence, machine learning, deep learning. So we spent some time in the paper trying to pinpoint exactly what we contributed. Because I'm an economist, and a lot of the paper in economics, they use broadly artificial intelligence. That includes everything from advanced software to big data to whatever. Everything has become artificial intelligence, but not really. Okay? So, and here we try to say, no, what we contribute is that specific area that is deep learning, algorithm-based, neural network-based, and specifically Hinton and the Banjo and Lee Kuhn are convolutional neural networks. That is what we contribute to. That is small, but ChatGPT is a big impact. Okay, small as a development, but huge impact in the future. So for those among you that don't know what they are, these were the fundamental data set back then in the late 20s. This is CIFAR 100, CIFAR 10. I explain you the difference. CIFAR 100 are 10 classes, airplane, automobile, birds, so on and so forth, times 6,000 images, annotated. And that's the issue. And I will try to convince you that these three categories, not too many types of well annotated, small enough, are fundamental for the success of the data set as the tool on which was possible to test the new algorithms. CIFAR 100 is different as 100 classes or 600 images. So same structure, but many more classes. So the fundamental difference between the two is 10 to 100. Okay, I will argue in a few more slides. Keep in mind this, that fundamentally CIFAR 10 was an evolution of what was before MNIST, and I will explain you what it was. And it was not so big as ImageNet that was too big, more than 1 million images. Right? So that were the characteristics, and the argument of the paper is that these specific characteristics are fundamental for the impact that it has. Okay, let me be more precise. A comment we received in the earlier presentation is, yeah, but how you can disentangle between the data set and the algorithm? Right? Because that's the question. And my answer has been, actually, when they asked, I said, I don't know, I have to think about it. And then I thought about it. Actually, there is no need to disentangle. Our interview, the 7 interviews, we managed to interview Lee Kuhn and Joshua Banjo. Not Hinton. Hinton we tried a lot of times. I will continue for the next 6 months because I want to talk to him. No, I want to close the paper with this comment because I'm very curious to understand if it was luck or he thought about it. Okay? He seriously structured the data set in that way or simply happened. By the way, the annotation of the data set happened during a summer school in Toronto finance based. Students did it. Okay? But the two other recognize, and Rob Ferguson, here in the interview, we have also Rob Ferguson, recognize that Hinton was the man behind doing that. But I really don't know, again, if he really thought it was simply, they decided to do like this, and that was the right form that was needed back then. So algorithm versus data set. The interviews tells us quite clearly then the two would not exist without each other. There is not a before and after. Okay. Yes, the convolutional neural network algorithm are extremely important, but without the data set, they would have not been developed because there was not developed before. They were attempted, but was very unsuccessful. So the argument here is not what is the causality one or the other, but there are two working together. and they are two coexisting. So there is no need of disentangling. And actually, if you read carefully the sociological literature on technosciences, they are actually making that the art craft, the technology, the data set here is undistinguishable from the science. So if you want to push that theory. So what do we do? 5 scientists, 2 Italian, quite prestigious artificial intelligence guys, the 3 out of the 4 fundamental actors in the development in 2008, 2009 of the data set. And then we interview 2 staff of CIFAR to have a bit of an inside view of the institution. I don't know if you know, I'm actually completely out of idea of the time. Okay, 15. I don't know how much do you know about CIFAR. CIFAR is a very peculiar institution. It's unique around the world. It's set up to finance, not much money, early stage, not understood, high potential, whatever high potential is, research. And they don't give money for research, but they give money for meetings, summer school, postdoctoral fellow, something like that. So we are really not speaking of a lot of money. No accountability, no reporting, no paper, no nothing. Okay, I do what I want. I'm a CIFAR fellow. Oh, wow, it's great. I get little money. I just do what I want, and that's really crucial. And the input is actually the meetings are the important part. You sit around the table. In our case, it's very, very strange. But okay, there are various most art sciences, and yeah, they're not completely disciplinary. They're not multidisciplinary, but there is some variety. So it's an interesting institution for financing very specific, not accountable and not performance-based science. Okay, second part of the analysis is the survey. The survey is done on 6,060. I'll tell it to you in a few more seconds. Doesn't matter. Papers. We explain it in a brief second. It's 295 responses. These are scientists that have published a paper on a journal or on a proceeding. Then, and it's the idea of Daniel, my co-author, he identified paper with code. Paper with Code is an open source website in this area that identifies data sets used for deep learning and publication attached to it. And so that was our trick to connect the data set to the publication. We didn't use the paper with code because paper with code is only open source publication. We went to Scopus and now we are using OpenAlex to get all the publications. Right? But the hook is there, it's paper with code. So it's community-based connection between a certain data set, CIFAR 10, for example, I don't remember exactly, solves 42 or 44 tasks, okay, problems. And as these papers have been presented at conference, because there you only have one. But the interesting thing are the data sets and the tasks, because then we use the tasks to identify similar data sets. So for us, the 207 data set here have been identified on the basis of they do at least one task similar to CIFAR 10 and CIFAR 100. And then in the econometrics, we put 10, 50, and the results are the same. So, but at least they solve one similar task. That's the identification strategy. And then we got publication and citations. Starting from this data set, we look. This was the slides. We look, we are here. We look in title, abstract, and keywords automatically for these 207 data sets. We identify 66,000 proceeding and papers published. This is Scopus. And then we went through a deep 3 months work, manual and automatic cleaning. And we ended up with about 33,000 papers that we are convinced, I would say 98%, that they're actually talking about deep learning. Pay attention, at the start here, for example, we had COCO. I don't know if you know what COCO is. COCO is the database published by Microsoft. Okay, next slide. These are the top 15 databases. Coco is here. And of course, there were about 8,000 papers that was coconuts, not deep learning. But the automatic search, pay attention to automatic search. Then we had another one here in the top 15. It was Prima. Oh, Prima is an Italian word. Okay. And then numeri primi, prime numbers. Other 4,000, 5,000 were paper deleted, and so on and so forth. We really went to check exactly, because every time you do name matching, pay attention to very standard names. So these are the top 15. They account for 8%, 80% of the population. So story is here. ImageNet, I already quoted, is the very famous one. MNIST, pay attention to the age, 1998 is one of the first. And these actually handwritten digit, one category, 7,000. And then Coco, Microsoft, and then CIFAR got published by the University of Toronto. Right? Look at the type, 10 categories, 60,000. Right? So if you look at these three, fundamentally, CIFAR is not too far from NIST, but there's more categories. Right? ImageNet is huge. Huge in terms of numbers and huge in terms of categories. Okay, Coco is somewhere there. Coco is Microsoft. Okay, lots of money. So we try to do some comparability. These first four account for about 55% of publications. And our argument is that CIFAR 10, if you want to choose one to compare with, is ImageNet, and then the rest. Okay. Okay, so let's go on. So here I introduced you the data. Let me take you through briefly the results of the interview. So the first major point that is bridging the gap. So CIFAR 10, here, pay attention, not 100. During the interview, we started with a feeling that was 10 and not 100. I didn't know anything about CIFAR 10 and CIFAR 100 before starting this project. Okay? Yes, I heard it, but I didn't know what it was. During the interviews, we understood something that actually CIFAR 10, that's what Michael said, and we verified in the questionnaire. It was a bit more than the MIST, but much more manageable than the image. In the regression, we put computing power, but fundamentally is connected to age, so it doesn't do much. But yes, pay attention, because the graphic memory in the computer used for games were then used for artificial intelligence, and then they were developed a specific one in 2004 and 5 for artificial intelligence. NVIDIA came on the market, so that has become a specific thing. So you really needed a new technology later on to handle the big data. In 2008, 2009, you did not yet have that technology. So size was important. Right? Computational capacity was important. And so somehow CIFAR was similar to NIST, but smaller than ImageNet, so was still handleable. So simplicity, enough to test and iterate different architecture without requiring extremely high computing power. CIFAR still run nowadays on laptops in classes. Right? ImageNet, no way that you can run that. Relevance for training in the interviews was done by students on the coding, and a lot of students were taught on CIFAR 10, exactly because in a class like this you can do it, and then the questionnaire will confirm they are still using it for training nowadays. They are students. So training has been an extremely important channel through which this specific data set became important, also because you learn to use that kind of structure, of course, in your Okay, survey, what we do, 6,060 papers and proceedings that have referred to, that have used CIFAR 10 and CIFAR 11. Okay? Pay attention, quite a large number of papers includes both CIFAR and other data sets. Exactly because CIFAR later on in time was used, we will see, as benchmark. We learn also this in the interview. I do a new algorithm. I make it run on a new data set, and then I'll show you that still works pretty damn well on CIFAR. By the way, 2014, it's been published a paper with an algorithm using CIFAR 10. I was trying to remember, now I remember. And the error in identification was 3–4%, compared to human, usually 6%. So by 2014, CIFAR problem was solved. So in theory, in science, once the problem is solved, you don't use it any longer, right? And instead here, we keep on seeing paper nowadays using CIFAR for that specific characteristic of benchmark. Okay, so they develop new algorithm on a new specific. If you look at the previous table, you see that, for example, here we have 2011, 2015, 2011, 2017, 2016, and then there are other 190 databases. Okay, lots of new databases out there, but quite a few of those actually they are using both ImageNet and CIFAR as benchmarking, and specifically CIFAR. So in theory, after 2014, you should not find CIFAR anymore if we were in a normal science. Okay, so we found 6,060. We managed to identify only 3,033 emails, some bounce back and stuff like that. Why? 81% of paper without email addresses are proceedings, right? So they don't put any, and that's a major. We did what we could. 295 answers, 9.4% response rate. It's not too good, but in science, sometimes you're lucky, and we were lucky. Okay? We did a response analysis on year, number of authors, journal article versus CD, international collaboration, number of data set, use yes or no ImageNet, number of citations. All of these, except the number of citations, are representative of the population. All of these are representative of the 3,000 sample. Remember, we have 2 steps here. Of course, citation is not. Why citation is not? By the highest cited paper, guess how many citations? 99 and something, almost 100,000 citations. Okay, my top paper is probably 2,000. Just to benchmark the contribution. So, of course, those guys, they don't answer to a questionnaire. Okay, and that's okay, is acceptable. But the rest is so alarming that actually this survey is robust. It's the first time that happens to me. I can say response analysis is good. Usually I hide it in the appendix. Yeah, we'll throw something, but here instead I put it there blue, very clear. Okay, what they are? Of course, doctoral student, 77, master student, bachelor, other, and so on and so forth. These are responses from the questionnaire, right? And where do they work? What I was telling you, about 20% are in the mix, 15% in industry, 5% in academia and industry, 77% in academia, right? We can do what we haven't yet had the time to do address identification in the full sample, but I'm quite relaxed about this data. We check a bit, they are not too different. I don't know how much you play with Scopus with the addresses to identify company, non-companies. Is a nightmare, but the first look, it seems that we are consistent. So the 2 important questions, very simple. This was 1 page. I love small questionnaires so that people answer. If you go more than 2-3 pages, no one will answer. So importance of CIFAR databases for the development of, we didn't know what, deep learning or computer vision, because in our interviews was unclear, and for us was unclear. And so we asked both. For the development of deep learning, for the development of computer vision, the first 2 are CIFAR 10, the second 2 are CIFAR 100, 44, so 75, 76 says that it is very important or extremely important. Okay, a bit more for deep learning, we weren't certain. Definitely, we were certain for computer vision. So no, it's even more important. So these are really the database that which deep learning has developed, or the algorithm developed in the early 2000s we use in this database are the fundamental algorithms. Look at CIFAR 100, it's still important, but much less. Okay? The most important part is this information doesn't answer, so they don't think it's okay. While if you look at CIFAR, almost 7-8%. Okay, so first, strong evidence that was CIFAR 10 confirming the results of the interview compared to CIFAR 100. Second question, we structure again on the basis of the interviews. It was this idea of characteristics I've been trying to sell you. Okay, how do we go? Data availability, access, fundamentally, open and easily accessible was the way in which we put the question. Comparability, the benchmarking I've been talking to you. Quality of labeling, number of images, size of images, and number of categories. Analyzing through the interview and interacting with IE colleagues in Turin, we identify these categories. And what it comes out very strong again, 10-100 is data availability, open access, simple data set, easily accessible. Now everything is open access, isn't it? But how many times you have tried to download a database and you said, okay, after BTS, I did it. No metadata, no information, no anything. Take home. Okay. This was the University of Toronto did a top job in making this thing accessible. Benchmarking comparability has become the standard. Everyone that was working on new algorithm or new database had to refer. And still you see quality of labeling. The other one is much. Here we are what 60, 70 in case on labeling, and also about 70 on number of images. Less so size of image and number of. So the only thing that we did not expect, and still important but not so important, was the number of categories. Right? Size of images because they were tiny images. Before CIFAR, there was 8 million tiny images data set that was developed by Rob Ferguson, but was not annotated. Okay? It was just here. But the idea of putting small images was Rob Ferguson. CIFAR 100, same story than before. It is some of these characteristics, but as you can see, much less. And you can see the gray, not used, not relevant, gets more important. So by now is CIFAR 10. Okay, I don't talk any longer of CIFAR 100. Pedagogical perspective, so CIFAR 10, about 65% were introduced to CIFAR 10 when they were EA, MA, PhD. Here, questionnaire design is a nightmare. Every time I did a lot of questionnaires, every time I made a mistake. I mean, it's amazing. I say, I'm so stupid. I know, it's very difficult. So I thought it was a nice question. Then when I tried to analyze it, I had to put the three together because the answer is strange way. So that's life. That's life. You do as best as you can, and it's best to put them together and use it. So my point here is not that one. It's in 2022-23, 51% of representative sample of respondents still use CIFAR 10 to teach. That's amazing. I mean, it's 12 years old data set. Okay. So is ESP really become the benchmark and the tool used to form the community? Why they keep using. Okay. What they are used to. So summary about this, I already did it. 76 believe that CIFAR were important, both deep learning and computer vision. We had a bit more expectation on computer vision, but turned the other way around. Open access and data characteristics are fundamentally, and again, relevance of training. I played here and I'm completely transparent, and I amazed. This is the community that is really devoted. 190 open questions, a large number. And I did that. I used ChatGPT to analyze them. And you will read the paper. It did manage to pick up quite well what our understanding of the interviews and all the questionnaire. In the paper, I discussed that a bit. I did 10 run explaining the prompting. After I managed to understand what the right prompting was, I did 10 runs, and then I decided what to write. To analyze 190 open questions, it would have taken me probably a week. and I did it in one night. So, and that's I don't present it, but it's quite interesting. It's the summary of what I did now. So last part of the paper. When did I start? 15, yes. So how long have I been going? Okay, let's say, yeah, 10 minutes, yeah? And then we open a bit to comments. So these are the publication of the databases of the top 15, 80% of total, CIFAR account for 18%. What do you see? You see fundamentally ImageNet, MNIST, CIFAR 10, and COCO, okay? Here you see CIFAR 100 and Pascal. And then the rest, and then here below 20%, there are the other 186. Okay, so much of the story is there. There's something, and so we take on the basis of this, our comparative and the basis of question. Or our comparative is ImageNet. Okay, and then we compare, we mix all the other 105 together. So we fundamentally have 3 categories to compare with. This is quite interesting. We had to play actually in this graph, we realized of the COCO effect. And we said, oh gosh, what do we have in this data? Suddenly came out agriculture, arts, and we said, there is something that doesn't work. These are the fields, these are the top fields, 30K out of 33, so the top fields are playing most of the story. Of course, it's computer science, but look at this connected to my next project, medicine. Okay, so here there are both fields that develop the technology and fields that are user of it. Again, a very important characteristic. User and producer, the literature of economics of innovation, the old one, or science technology linkages. So you have quite, if you see that light green is present, right? In all of them. Again, these are older. Other is the 192, 93, whatever is the number. Imagine that MNIST COCO is present in all of them with some okay. This is just to tell you that this, yes, is science field, but there are applications there. By the way, we are in engineering, of course, the gray is engineering, right? So it's engineering and computer science. So what do we do? I will try to convince in the next few minutes that what we do is robust, but fundamentally we start with a Poisson model because these are extremely skewed distribution. Our dependent variable are outcomes. Here, outcomes means citations in papers, citations in patents. I will explain a bit. We use a full sample, 2010, 2019, COVID, and we stop. 2 days ago, we ran to 2022 results. CIFAR is 13.6 in the 12,000 sample, right? The reduced. This is the quite robust reduce. We try to be as possible as everything. And then we did a very small sample. In the appendix, you will find it with 6,000 papers. Are fundamentally only computers, so only the producer. Did we narrow down? We narrow down with at least 50 papers in the that has used the data sets. So we take away small data sets and at least 10 tasks overlapping with CIFAR. So we really compare with papers that are very similar to those that have used CIFAR 10. CIFAR there becomes a bit more representative in the sample, of course, robust results of the best. Then we do the split sample. I already told you why, 2014. By 2014, CIFAR problem was solved. It's there, so theoretically, we expect to find a much more important impact in the first phase compared to the second. And actually, if we were to find still an impact in the second phase, that would be interesting because there are new databases, there are new data. So why they keep on using CIFAR 10 also after 2000. So our hypothesis, if you like, but our hypothesis is mainly impact in the first phase before 2014. Again, 2 days ago, we rerun till 2022. results robust. That I already told you. Okay, that is the setup. We have two main number citation variable, total number of forward citation, 3 years windows. Now we are working using 3 quality impact characterization indicators. So we are working to characterize basic versus applied type of journals that are citing this paper. We are working at weighing for impact factor and for citation scores. But as you will see, the results are quite strong, so I don't think anything will change, but still, I will do all the tests. Actually, I have an hypothesis there, but yet not run, so I can tell you about the basic versus applied. Number of patents, total number of citation by patent families, US, EPO, WIPO, IPO, JPO. So we distinguish, if you want scientific, the first versus technological. Same type of results. You can read, yes, you can read. We have lots of controls, and we keep on increasing them as much as we can. Publication. This is journal versus proceeding. My 2 co-authors, I'm Italian, 1 Brazilian, and 1 Costa Rican. So the English of the paper is still a bit shaky. I said it's something as I don't know. Fixed effect. So the fields you've seen before. Calendar year fixed effect. Right? Number of authors, number of references, international cooperation, affiliation, number of data sets used, because you expect that more data sets used on the paper, more will be cited in the future. Number of tasks, again, the more tasks the paper solves, the better it will be in the future. Number of modalities. I will tell you in 2 seconds when I get check on the paper. Anyhow, the major results are up here. Okay? We put only CIFAR in, full sample, no effect. Period 10-14, huge effect, 226% increase of citations in terms of elasticity. This is exponential, is it possible? Negative, non-significant second period. The comparative there are the 206. Can you really compare with the database of 2021 with only 3 papers? Probably not. So we pull in ImageNet that we think is our competitors. And what we got, again, full ImageNet is more. ImageNet is being closed, the competition in 2017, but it's still there. People are still challenged by the size and the complexity. So the competition is run in 2017 for what, 8-9 years? So every year was a competition, and one algorithm won. By the way, the first one to win ImageNet in 2012 was Alex, whatever the name is, that's strange, with the algorithm that has developed based on what? So it was a student. He never finished his PhD. He doesn't answer my emails. He doesn't using Google or Facebook or whatever. But without CIFAR, he would not have developed his algorithm and one image. Anyhow, this is because I like story and I like data. What you see here is ImageNet, split sample, still also compared to. So this is CIFAR compared to the other one, ImageNet compared to the other. In the first period is CIFAR. No, they were published in 2009. Okay, same year. In theory, was ImageNet. No, was too big, too many images, too much, too complex. We would not have been here without CIFAR, but only with it. It was not right for the computer power and the competencies of science of the second period, of course, ImageNet. Okay. Now we go to this is actually the coefficient representation, because it's the yearly representation. Black is CIFAR, red is ImageNet, and here you see ImageNet that goes a bit above, and you fundamentally see a big drop on CIFAR. So that is aggregate estimation. This is yearly difference, even in the second. Yes, ImageNet is better. Okay, but I mean, our hypothesis was the first period, right? What it comes out, again, we did not expect, is the technological, right? Alone, full, positive, again, huge in the first period, comparing to CIFAR, higher in the comparative, in sample, super significant in the second, and still higher in the third. Okay? CIFAR 10 nowadays is still used in patents. Okay? We thought a bit about it. Okay. And I think now we are pulling out these citations to understand. Actually, what we think our hypothesis is that patents are citing the seminal work, right? The early works in the field. So we expect that those citations are actually to the first year. There are around 1,700. I think there are 250 papers using CIFAR time. So we think that are those papers seminal first 20, 30 papers. But now we have to go by hand through all the citations and identify them to interpret that result. But I think it's a very fascinating result. I've never seen it before in field analysis. So a clear differential. What we do for robustness, check almost everything. We went in alls, seen, negative gain, better results. We did the reduced sample, I already told you, better results, more robust results. So what we present is the less robust results, just to convince you that it's okay. The next few steps are, yeah, you don't convince us that you really compare Apple with pairs. So we use the usual story, propensity score, we match course matching methods, and then we do a difference with the subsample match so that we have one specific CIFAR paper, we associated another one with other database, and we go and reduce it. But again, look at the significance, and in the reduced sample, the significance is very strong. By the way, this is 5%. Okay, so 3 star is 0.001. Okay, we don't expect that much change. But okay, for robustness check, we need to do the correct still this result seems quite good to me. So summary, scientific impact, yes, CIFAR 10, first period, they got 226, 130, 209. So we are obliged to put them. So more than 2 times citations than other datasets, similar datasets. So it was indeed extremely important. And the argument here was and is important for technological development. So I conclude highlighting fundamentally 2 effects. What we call the direct effect, so through citation. So we claim in the paper, actually CIFAR 10, not CIFAR 100, was the artcraft fundamental for the development of deep learning, and computer vision is a subfield of deep learning. So, but our evidence speaks about in the interviews and in the questionnaire about deep learning as much as. Second, what we call it indirect, about this, is teaching. Teaching is important. A lot of time we are so much focused on research that we forget that universities are co-production institutions. There is teaching and there is research. And definitely in this case, there is indeed a very strong impact through teaching. What we are trying to do, I don't know if in this paper or in another paper, is to collect the year, there is a data set in the US, year of starting of deep learning courses in the departmental level in a large sample of universities. And we want to play a bit more to try to see if we can bring in also in the econometric analysis a bit of teaching. But I think this paper has enough for closing there. Okay, thank you very much. What?
Yes, so I have multiple questions, but I'll go directly to my point. First off, do you see a relationship with the adoption of databases with the S-curve of technology adoption? Because I see that you showed us a graph, and we saw that there is this adoption citation of papers according to the database, and I saw like, oh, this is just like technology. When new technology arrives, no, it's not.
No, I know.
We lose the old one. Second, you said you cannot distinguish between algorithm and database.
Okay, can I take a answer?
Yeah, sure.
It's technical. The first one, I deal with the first one. Proceedings versus papers, COVID effect. Okay, so there is a huge drop. Yeah, this is special 50% of the outputs are proceedings. Okay, so let me go back to answer to your question. I think that's the graph you wore. Okay, that plateauing here that you see is driven by 2002, COVID 2019 is driven by the decrease of conferences and therefore proceedings. Okay. Second point, CIFAR is the green, COCO starts in 2014, CIFAR in 2009, then we start in 2010 because both ImageNet and CIFAR 2009 coming up 2010. MNIST, that is this one, is 1990. So no, it's not an S. This is I don't know what it is. It's a good question. I'm not saying. I don't see it yet. It might be. What for me, what is interesting that these and these, so MNIST and CIFAR, they are solved problem, they are still used. So they're still there. Yeah. For sure, CIFAR, I didn't study MNIST. So there is the use and the benchmark part, and the benchmark may change completely the diffusion curve.
Second question is, you said that you used ChatGPT to analyze some of your results. What are the ethical implications of that? Because normally when we do a survey or work with humans subject, we have to sign that, oh, we will not disclose that information. But then the data is on ChatGPT and it's somewhere else. So now someone else has this data. So how does that fall for you?
I'm Italian, so I can answer very relaxed about this. In any data collection that have been done, and I'm willing to go to the European Court of Justice on this. On any data collection that have been done in the last 30 years, I've signed a document that in my office, there in the corner, there is a safe. A very serious, big safe, in which I keep the names of the people, and here on my computer are anonymized. I don't have a safe. I never had a safe. Okay? Data Protection Act is a major limitation to free scientific research. Point. That's part of the answer. Second point, yes, you're right. I fed ChatGPT with specific information, but I don't have the names. So it's just answer the question. So it's okay. Third answer, I did it because I was short of time. We are pressed for productivity, and I was very curious to see those 190 questions, but I didn't have time. Properly, when the paper will come out in a journal, I will redo my manual analysis, and actually in the methodological part, I will write 2 paragraphs, human coding, ChatGPT coding, what did I learn? That's the idea of our, and that kind of solves and contributes a bit what should be the big discussion here, but across sciences, how we will use ChatGPT, and then, okay, it's another discussion of tomorrow. I don't know if you're going to be there tomorrow. And the role of the public funding compared. Oh yes, it's tied to this. Actually, I can do it longer answer. CIFAR was little money, right? It was really peanuts, and was small. Would run nowadays on a simple laptop. ChatGPT, right? We don't even know how much computing. And we know, however, that parameters are thousands now, and layers are God knows how many. So the view I think, shared by a lot of artificial deep learning scientists, is that actually really know very well what's happening inside there. OpenAI is not open. Is not open. The third one I can't remember is not open. We don't know what is happening. Yeah, it's gonna shape, especially in sciences. Tomorrow, not in 5 years. Okay, so we need. Sorry, I take the opportunity in any space. We need to make a huge public funding in something like CERN on the generative AI, so that we, as a community of scientists, have something that we can study and understand what is going on. So that's the answer, but we can't stop it. I'm going to use ChatGPT. Yes, I will. But with caution, and this will be always mine.
That brings me to my third question.
Okay, go on.
And that's the last one, then I'll leave for others. You said that we cannot distinguish, I think you said something like this, we cannot separate between the algorithm and the database, but I mean, you just said that we just separated, you just separated it for us. There is the database on which the algorithm is trained, there is the method that is used, and then there are the parameters. And these are 3 distinct components for me. And if I change something in the database and I use the same algorithm and the same parameters, I will get something else.
Sure, but what I meant, okay, this I need to take a note. What I meant is, I'm an economist, and I have the disease of causality, the identification of the what is the independent. And the point is, why did you cite? Those are publication of the citation. This is the citation, right? Why do you cite those papers? Because of the database or because of that? That's my question. And I disentangle that. And my answer is, okay? Because one with the other would not work. The two are interrelated. The question is wrong. Not that I can't and I'm not able. I spend a month. So and then I really, but seriously thought, no, this is, you cannot separate art craft. This is a challenge, yeah, from the science development. Without that piece of technology, the science development would not be. So it's not who's first or second, because the question is fundamentally, is the argument more important than both? Exactly as you said, I mean, certain algorithms, certain characteristics on certain databases, and the power of CIFAR has been that was handable with certain characteristics that was good to run alternative configuration of algorithms. And that's, if you want, but I can't measure way this. So
I know I said it's the last question.
No, you can send me an email.
Firstly, thanks for the presentation. It was really interesting. My question is your view on synthetic data. You mentioned, we're talking about sort of broader generative data creators, but more and more it's been said that by year 2030, 95, if not 98% of the whole data, including images, will be synthetic. So have you seen, and if so, and if you haven't, what do you think, how the graphs, with citations, knowing that exactly what you mentioned, why are we choosing those data sets for the algorithms or for the images themselves? How do you think they will, in the next 8 years will happen? And if something, like a new CIFAR 10 synthetic wise, or if it will be just a bunch of, sort of now, with a click of a button, you can create, as many pictures, random pictures as you want, almost. If you think it will change drastically, or or researchers in a way will not mind or will not follow that trend as much.
Very interesting question. out of my competence. If this is a technical question, I can give like this a feeling based on what I studied.
Sure.
Quality of the image, what it is 20, 15 years ago, did not matter. If you look also at the response of the questionnaire, quality, where it is, size of images, that was fundamentally the quality of the image. Important, yes, but, and this was 15 years ago. ImageNet has many, many, many more categories for images. The size, I mean, the challenge here was, of course, a small image, blur image. That was the issue. I didn't explain. If you look at the first picture, actually, they're pretty bad. This is the original picture. So there were small pictures of low resolution. That was the challenge. Can an algorithm be able iteratively, because the trick of convolution, here I don't have to explain what convolution is the feedback and then get to a target. Your question is if we improve the quality, if we generate many more, if I understood.
No, the question is, do we have to rely on such type of databases
Any longer.
any longer, knowing that we can just, synthetic data, irrespective of the, you can create lower quality, resolutions or not? Or do you think that will still be relevant for researchers to go, if I saw correctly, for example.
It's not extracted from the web because they come from 80 million tiny images. So the effort by Rob Ferguson to extract images from the web and make them recognize. The objective is, can we develop a software that is able to recognize images? Of course, self-driving car, diagnosis, and so on and so forth. Do I care if they are produced synthetically or not? It depends on what is your objective. I don't think any longer we are in a science framework. In ImageNet is 2007, the competition has been closed. It's finally also that kind of result. We have moved to the phase of application. So I'm trying to give you an answer on something that I don't know. So the issue there for me is what's reality, and therefore what are used these are algorithms. If you feed them with synthetic images that are not representing reality or that are biased in some way or another compared to reality, then you're training them in a biased or non-real way. So I turn the question to you fundamentally. What is the use of the algorithm? And once at that, nowadays the image databases are they're not any longer so important.
On va prendre une question en ligne.
Ouais.
Une question en ligne. David Labalade.
So sorry, I touched it. Let me check. Fine, there is my image or not. Yes. It's you. Okay. Just for the people online, I'm thinking to Edgar that to try to put a question on the chat. So if you want, you can open your micro and you can make your question on the microphone. So for everybody on Zoom, you can do the same thing. So open your microphone and make the question. And for people that are following us on LinkedIn Live, you can write your question if you want in the comments of the video, and our staff will turn the question here to Mr. Aldo Geuna. So we wait for, no, Michael will have a question. You can probably put on.
Can do it now?
Why, yes.
So my question is the following. At the end, you use two impact measures, like the number of stations for the patent and the one for the publications. And I wonder if you considered other impact measure, because it seems that the characteristic that you used that are defining, for instance, the convenience, the interoperability, like all these factors that makes it really easy to just use bench. So I wonder if other performance measures could give another like a portrait, like and also like if these results shows how much it is interesting, like from a experimental stage and for like education and so forth. But what about like the real outcome in terms of its impact on the deep learning progress? Like.
Okay. Yes. 3 quick answers. We have been playing a bit with altometrics, but I don't particularly like. Daniel wants to put it in, I resist. I think it's something else. The theoretical question here was indeed the impact on science. So the coming up of deep learning. We measure it in such a clumsy way that is citations. I don't have better ideas in the sense that where we are. Yeah. Now we are going to wait. We are going to bring. Now is quantity. Okay. So what we have to do is to bring it to quality. Impact. Okay. Whatever you want to call it. It's not quality, but that's the way to give a bit more. So. Top 1%, top 10%, impact factor. So we're going to do all of that to qualify better. And the first one is science, is what you're asking. If you have a better suggestion, give it to me. No. But truly, as an open discussion, tell me what to do. And the second level, and I didn't tell you actually, we are planning also for that, to try to disentangle a bit the value of that. And therefore, we are going to use forward citations, so patent number weighted by forward citations, patent number weighted for court cases. And we have collected those data. And then we try to play a bit on I like that, I'm one of the few that are using it, basic versus applied, what that means. That in patents, and actually you might be interested. Max Marks as a series of data sets that are open, and among which there is a new one that is classifying journals in applied versus basic, because the classification I'm going to use is the CHI NARIN 1976, updated last time by the National Science Foundation in 2014. Then there is a okay, all that done. This thing instead is new, so it uses citation patents to classify journals as with more input, with more applicability. So we try to play a bit around that. The patents is as best as we can go. I don't think that within this paper we can. It's already, we are at 49. Yeah, we will end up by 60 pages. Will become a working paper, and then we will have to cut it down to the usual 8,000 words to publish. And then there will be a huge online robustness check. But yes, we intend to do. And if you have any suggestions, thank you. Tell me. Yeah.
Est-ce qu'il y a une question, Ali? Aldo, I'm just wondering whether instead of number of citations, whether you use mean normalized citation scores. Because you mentioned that you were only looking at computer science, or are these regressions all sectors? Because the way they cite in medicine is very different from engineering, from computer science. So I'm just wondering whether some of it might be a field effect as opposed to mean normalized citation scores, which would be normalized by by sector, even if you have sectoral fixed effects?
Something like that. No, yes and no. That means is within the robustness check we have to do.
Okay.
For the time being, it's total citation, 3 years windows. Given the fact that was fixed effect. No, there is not only computer science in the 13,000. Yes, there is only computer science practically in the 6,000. Okay. When you go to the reduced sample, results are all 0.1%. That is quite interesting because you reduce the sample and you get much higher significance, so you fundamentally reduce the noise. But yes, I think we should try to do also.
In your questionnaire, did you ask individuals, do you feel obliged to cite CIFAR 10 because you didn't want to offend anyone? So you have to cite Hinton's work, and so you do the work on CIFAR 10, and then obviously you do other stuff. Is this a kind of legacy or celebrating the Godfather in himself? Or I'm just curious. I'm just curious.
You know, to be clear, we do not look at citations. We look in the abstract, in the title, in the keywords, a combination of CIFAR 10, CIFAR 100 database, computer vision. So we do a text analysis, right? So we are interested in capturing the database use. So we look for used CIFAR 10, implemented on CIFAR 10, something like that. CIFAR 10, CIFAR 10.
But not why, not the why.
No. So was to tell you, I think they haven't cited the fundamental, but I don't know. But they used.
But I mean, regardless of whether they cite it, the fact that they use it, they
but
must.
that is the benchmark. I mean, it has become the benchmark. Now, here I'm really trying to disentangle the citation. That is your, and I understand what you're asking. Right? That's the very nice. How many students there are here? Doesn't matter. That's no, I mean, we cited, I mean, lots of scientists, not us, cites in a very sorry way. That's really bad, at least in social science, it is a disaster. I see young students that, I mean, whenever you do the network analysis of citations, it's so much cluster. The old work of the 60s and 70s sociology that was small, now you do them big again, people don't work. I don't trust citations. So that's the answer. Yes, you're definitely, and we need to do better work on citations, not quality. But here, our unit of identification is the data. So we are not getting the papers that have cited that, and that's what we survey. And then we look at citation to those papers. Okay, so it might be that in those papers, Hinton has not been cited, but I will check 10 of them and put a note. This is a nice question. As far as there are 3 that they don't cite Hinton, but they use CIFAR, another thing.
On va un instant parce qu'on a un problème technique. Tout déjà passé?
J'ai apprécié, mais ça marche pas là.
Attends. Le système est en lag là.
Okay.
Sorry, no, we didn't ask that question.
Oui, pas le
Because
répéter.
we was very smooth.
I've wondered if you've thought sort of the still relevance of CIFAR 10, knowing that, you know, after 2014, it should have been, you know, sort of solved. The fact that that science, fortunately, is being spread out, and there are many countries, you know, sort of in developing countries, like many places in developing countries that do not have the resources. And like you said, that it runs in a laptop, and that, you know, more and more.
Yeah.
Sort of
We are trying actually to do this paper.
okay.
That was our hypothesis.
Yeah.
Look at this country public publication, CIFAR publication. That's another paper I don't know when. Also, this has to be weighted by impact and blah, 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 blah. China, United States, Korea, India already there. Japan, India, Canada, of course, they are. But then you might start to go down, but not too down. Turkey, Iran, Russian Federation, Spain. I'll do it. So yes, we are very much interested, because that was exactly our hypothesis, to understand if nowadays in less advanced, whatever you call it, we took the World Bank classification and we started to play a bit around with that. Where should we put it? Okay. So before then we stop because we had to produce the paper and take it around. And this is with other two students I have, I told them, okay, you start to work. And then they come, but the idea is first we use a citation, an impact, whatever you want, weigh these numbers and reproduce them. And then we need to come out with a decent science founding classification of countries. Because sometimes there is a discrepancy between GDP per capita and science funding. And then we try to do it because we are very much interested in the usual aspect. So the first paper is new science, right? And then the second paper is geographical diffusion of a new science across the world. That is not expensive. So if you want to pool, to take one policy implication out of this paper, we haven't yet written the policy implications, as usual, is actually, yes, a cheap, open database, easy to use. That might have multiple effects, generation and diffusion. And the second one is diffusion. Hopefully we will be able. We have played a bit, but there was not the killer results. And so we said, okay, let's put it on the back burner and then.
Thank you.
If there are no questions, I might venture kind of nice story from your paper. I think it's pour faire du pouce sur ce que tu as dit, Alvar. I think it's important that it is still being used in teaching. And this teaching network provides the stepping stone on which science is built. So it's basically, you're making an argument for opening science and joining that with teaching. If you just have open science or just teaching, then you wouldn't have this snowball effect that you have in there with CIFAR, which is somehow very small, easy to use, run it on a laptop. And that's the second paper will be very interesting.
Yeah.
But this is the policy. You want
unfortunately, it's very difficult to put it in the econometrics. But that is what we are trying to think about in the second period into 22. Trying to see if we are able to do something on this teaching effect in quantitative terms to bring it in the econometrics. Now we haven't time on one side and a sufficient good idea. But yes, I was, as I said, I was fascinated by this teaching effect because they are increasingly polarized. And lots of European countries that has went to performance metrics, the result is actually decrease of teaching. Because scholars, not researchers, were pushed to, and they were evaluated only on publication, things that before in France, Italy, Spain, and Germany did not happen. And therefore, they substituted teaching time with research time. Such a research. To be, okay, there are researchers and there are scholars, that's life. But scholars are important and they have to read and study because they have to teach. So, but yeah. But still, the qualitative results are interesting. I want to bring it together with the econometrics. But yes, that's very fascinating. Yeah.
I have an idea for you.
That is why I'm here.
So I have an idea about the econometric for you about the teaching aspect. Maybe you could look at the Wayback Machine and look at the
Sorry, couldn't understand.
Wayback Machine.
Wayback Machine. Yeah. No.
And then go back in time to see the how do we say course curriculum, like a plan cours in French, would say like
there are lists of Course curriculum.
Yeah. And maybe you'll get like some keywords about that could be maybe they mention in the curriculum if they
Yes,
use it or not.
but that is what we are trying to do with the US database. But what is your expectation in the regression? Because that is what is not clear to me. If I put in on a yearly basis the number of courses that have used CIFAR 10, that is what we are trying to do. What is the correlation with citation?
So
Positive, there should be a lag. How do I estimate the lag? I'm asking the question and then you send me the email with that. But yes, we need to play around there, but I haven't yet got the model in my head.
the idea would be like to flip the independent variable into the dependent and to have the whether or not it was used in the paper. The CIFAR, like the data, the algorithm, like if it was used or not, and then you could have that as a marker and then have a kind of simultaneous equation system that could look at.
So you explain the number of courses that have used CIFAR with the number of citation to CIFAR.
Yeah, so the number of the curriculum will explain the number of papers that use CIFAR.
Right, yes. Okay, is another model? Yes.
Yeah.
Yes, that's a good idea. I can run that only for the second period. At the lag, 3 years lag, assume that is PhD training, 4 years lag. And curriculum, entering the curriculum, publication, citation, whatever, on this, publication and citation on the right-hand side 4 years before, and then, okay, yes, that's good. Okay, thank you.
Moi, je pense que ça va être une conversation à suivre. So, Aldo, I
Hey,
think I will.
je dois écrire ça.
Tu dois écrire ça? Bon, OK. So, why don't you write that? Parce qu'il y a un texte dans.
Okay.
I think I need to bring you downstairs.
Yeah.
Okay. Bon, on va terminer. Merci beaucoup, Aldo. Je pense que tu as suscité beaucoup de questions. If you have questions online and you want to send them to us at 4.0, then we'll take them and send them to Aldo. I'm sure he'll be grateful for the questions. So
If you want the paper, send me an email.
yeah, we'll send you an email for the paper. And well, thank you very much for the people online, people on Zoom, people on LinkedIn. Merci aux gens qui étaient présents dans la salle. Donc, merci, bonne journée, puis bonne semaine à tous.
Okay, let's go.
Merci, Martin.
Merci, au revoir.